Starting. All attendees are in listen-only mode.
Alrighty. Welcome to today's presentation sponsored by Precision International. Thank you, Precision International, for making this available to everybody. Also would like to thank you to WIT, Whatever It Takes, Gears Magazine, Ray Bestis, TransStar, ATRA, and of course Precision International. Precision International received a of the Year award for 3 consecutive years. That's quite impressive in my opinion. Also, Precision International also would like you to welcome you to give them a call, 800-872-6649. Also, you can email them. Information is on the left. Text message 631-245-3375. They have to offer a free flash drive with roughly 80 plus tech tips and videos. Also, I believe you can find their information also on transmissionkits.com. Videos including John Paul Minner and some other of their speakers. Some interesting videos on their warehouse and some of their staff that's there. Great tech videos and updates and stuff like that too. So well worth the time. Go to their website, give them a call, text, and have that flash drive sent to you guys. Thank you, Precision International. If you have any questions, comments, or concerns during the presentation, please go ahead on the questions tab, type in your question, and I'll answer it as soon as possible. We try to get to the questions as we're speaking to come up with the best solution possible. Always like feedback. It just makes it that much better. If you have not downloaded the handout, go ahead and do that on the right hand side in the PDF file. That would be good information to do, so you can refer back to it later. Also, you can refer back to it on the ATRA website under the webinars tabs. After the webinar, if you have any questions, comments, or suggestions about upcoming webinars, please give us a call or email at webinars@atra.com. You can also, of course, give us a call also to talk to us. We have a short video from Precision International.
Precision International has been proud to have been named a GM Supplier of the Year for 3 consecutive years by General Motors. Kits.com for up-to-date product information, rebuilding tips. Precision International's 80-plus tech and 1-800-8. Send us a text to at Precision.
Possible by my house. Some of the Honda vehicles that this is found in is the Accent, the Elantra, the Santa Fe, Sonata, Tucson are a few of the vehicles. On the Kia side, Forte, Optima, Sedona, Sorento, Soul, Sportage. This was an interesting fact that I found during the process of making this webinar, but it's a 6-speed versus the 5-speed. Over the A6MF1. Some of these are improvements, and some of them I don't think there are improvements at all, and went backwards. They got rid of the filler tube. To me, getting rid of the dipstick is not the smartest move. It does not make it very service friendly, in my opinion. So I don't think that's an improvement, but they classify it as one. They've done some redesigning on the return springs to reduce the length of the transmission. They have a super flat torque converter, which is roughly about 1 inch shorter than a normal size torque converter for this transmission. They improved the pump. They improved the transfer gears, lubrication, differentials been redesigned. Axle seals are now in the spider gears for the most part. A lot more stable and secure. Less axle seal leak problems. So that's an improvement there in my opinion. The valve body has a bunch of linear solenoids, like the AW series transmission is very similar style solenoids. Another thing I don't think is an improvement, but they classify it as an improvement, is a single body harness. It's a flat ribbon style, kind of like the Volkswagen O1M transmission. In my opinion, it's very independable, and they're definitely having some issues with the temp sensor and that ribbon. So that's not an improvement in my mind. The one-way roller clutch has been improved. So those are some of the improvements over the 5-speed. Here's some of the gear ratios. You have a wide ratio, a close ratio. Also have a bunch of different transmission models and engine size. To sum it up, the A6MF1 transmission is found behind the 3.3 liter engine, and that's the close ratio transmission. The A6MF2 and 3 are found behind the 3.5, 3.8, and 4 liter engines, and that's a wider ratio transmission. A6MF1 is behind the 2.0 or 2.4 liter close ratio transmission. A6MF2, the 2.4 liter is a close ratio, and the 2.7 is a wide ratio. So you can see a couple different ratios and a bunch of different models, and it can be very confusing. So we need to definitely pay attention to our transfer gears, our gear train, tooth counts, and also differential tooth counts. As you see, fifth gear is 1-to-1 in all these transmissions. Most of the differences in between first and second gear on the gear ratios, for the most part, being wide ratio or a close ratio. Oil fill procedures. They call this an improvement, but I do not think so. They got rid of the dipstick tube, so now they have a vent cap on top of the transmission, like a bongo fitting style. Basically, remove that plug, you fill oil through that valve body plug cover, vent cover, at the top of the valve body cover. At the very bottom left-hand corner, you have your fill level plug. The old style, this used to be a metal tin cover. The newer ones are a plastic. This is the original style. Here's the updated or the second design style. A couple things I'd like to show for you on this. These are not threaded inserts. They're more of a detent kind of lock. So close it. You got a 3/8 plug right here. Square ratchet driver extension works real well. Loosen it, roughly 3/4 of a turn, little less, and then it pops out. There's just a detent lock. There's no threads in this. We see a lot of these get stripped out, cracked, broke, and warped. So pay attention when you're messing with the plugs on these. Do not use an air ratchet or anything like that to remove that plug. Oil fill level procedures. ATF SP LF1, 2, and 3 uses 8.3 quarts. A6MF1 and 2, 7.5 quarts. Drain and fill, you're roughly right around 5 quarts. Fill up the transmission through the vent plug on the valve body cover. Fill it with SP4 fluid. Warm it up to 122 to 140 degrees Fahrenheit. That's 50 degrees to 60 degrees Celsius. Verify the temperature on the scan tool. We need to make sure temperatures are correct, or you're going to underfill or overfill this transmission. We want the vehicle running. Shift it through your gears. Park, reverse, neutral drive, back up to park. While it's still running, pull the fill level plug on the valve body cover. Oil should be level with the bottom of the plug, so just drizzling out the bottom of the plug there. Metal style PAM. Torque the plug down to 5 to 10 foot-pounds, or 7 to 10 foot-pounds. The plastic is about 3/4 of a turn to the detent stop. Clutch components. I want to take a look at this. A few things on clutch components. We have your 2.6 clutch up front here. Your 3.5R clutch next. Undrive brake in the back. overdrive clutch, and your one-way sprag. I like to keep things simple. So, in my opinion, I think this is a GM 6-speed. Take a look at your underdrive clutch, or your underdrive brake, I should say. It's on first, second, third, and fourth. I call this the 1, 2, 3, 4 clutch. 2-6 clutch is just that, on in second and sixth. Low reverse, start the engine up, it's on. In park, reverse, neutral, and in first gear. This roughly shuts off the low reverse clutch, or low reverse brake shuts off. I'm going to say right around 5 miles per hour or so. Kind of like your 6L80s, 6L90s. It turns the low reverse clutch off at roughly 5 miles per hour on acceleration. 3/5-hour clutch is just that. It's on fifth, third, and reverse. In the OD clutch, I call it the fourth, fifth, sixth clutch because that's what it does. It's on fourth, fifth, and sixth gears. So just memorize the GM 6-speed, and you got the 6 speeds pretty much covered for all manufactured for the most part. We have your 3-piece case basically here. We have torque converter housing, main range switch, and your solenoid plug or solenoid connector is right there next to your range switch. We have seen some issues in that solenoid connector for corrosion, and some solenoid codes. Usually it is a ribbon. Inhibitor switch. It's like a lot of your inhibitor switch, nothing fancy. It runs off of 12 volts, S3 and S4. If you had a range switch code, go to park. On your scan tool, look at S1, you should see 12 volts. S3, you should see 12 volts. S4, you should show 0 volts. Move your shifter reverse. Take a look at your scan tool and see what you have. S1, 0 volts. S2, 0 volts. S3, 0 volts. S4 has battery voltage. And so on down the list. See, if you have range sensor codes and you want to see which wire is bad, look at your scan tool and go over each switch wire and see which one is not changing. Let's say if you had a problem with your S not changing, connector back probe this terminal right here. Shift it from park to reverse. Does it change? And then back to neutral. Does it change? You should go battery voltage, 0 voltage in reverse, battery voltage in park, neutral, and drive. Switch to diag your range switch. The shifter in neutral, you can stick a drill bit right through the bracket here and then range switch to line it up, make sure it's lined up properly. That was roughly an inch drill bit. Correct. Here's a solenoid electrical appliance low. So it's flowing oil to the clutch. Flowing oil when it's normally high. So normally high. So we know our clutch is fourth gear, but the solenoid is not on. To get this to flow oil to the clutch, you have to turn the solenoid off. So in park, reverse, neutral, fifth and sixth gear, this solenoid has high amps to turn the oil off to the underdrive clutch. So when it is in first, second, third, and fourth gear, it has no amps to that solenoid, and that's when that solenoid flows full oil. You see lockup solenoid here, starts lockup in second gear. In fourth gear, so when there's no power to the transmission, it's going to have fourth gear failsafe. As you see here, normally high 6 in the torque converter, normally high line pressure control, 3/5R, OD, and UD. These are all 5.1 ohms roughly on all the linear style solenoids that will be on the slide. Here is, if it's this style, it's early style 10%. Here's your solenoid layout, line pressure solenoid here, shift solenoid A, shift solenoid B, OD, UD, 2.6, 3.5, and torque converter, all lined up in a line there. Makes it kind of nice to work on. The ends of the solenoid are going to have some different colors on them. Different models are going to have some different colors. The normally high will be one color, the normally low will be a different color. the on-off solenoids and the line pressure solenoid will be a different color from the other solenoids too. So you usually have 4 different colored solenoids on here. Line pressure solenoid, high style solenoid, operates 50 to 850 milliamps. The valve is down on this picture. You see how the valve, you see it's open here. Solenoid feed oil comes in between this land, through that valve opening, out this land, and to your clutch or to the circuit. Your normally high pressure control solenoid is also like 35R. The 35R underdrive and the overdrive. Forgot which one were the normally high. Sorry about that. So we're going to talk about the 35R underdrive and overdrive. They're going to operate the same as this solenoid. Feed in the bottom, and it controls out here. And you see the valve is pushed down. When the solenoid's on, the valve moves up to the top. As you see this portion here, the feed oil now is blocked. So there's low pressure coming out of the controlled pressure area right here. So that's a normally high style solenoid, and the 35R reverse, the underdrive and the overdrive solenoids operate just like that also. Torque converter clutch and the 2.6, that solenoid is normally low solenoid, 850. Alright, so the solenoid is off, the valve is moved to the left in this picture. As you see here, solenoid feed comes into this passage as the valve is being blocked in the solenoid snout. So little oil comes out this area here to your circuit. Solenoid is on, valve is pushed over to the right. You see in the solenoid snout where the valve is opened. Picture shows it's open right here. So oil is fed through here. This passage is open and oil goes out there to control it to the circuit, to the solenoid. Controls the oil to the clutch pack or the torque converter itself. As we talked about earlier, 35R reversed, underdrive and overdrive line pressure control solenoid. On-off solenoids are on the left-hand side here. This solenoid's off, the valve is pushed up, feed is going in here, and oil is being exhausted right here. When the solenoid's on, the valve is pushed down, feed oil is going through here, the valve is plugging it, so there is no exhaust. Those are the on-off solenoids. And to the next screen, here we go. Connector pinout information here. Number 5 is solenoid power number 2. Number 5 powers up solenoid B5 reverse, OD, and the TCC solenoids. So keep that in mind if you're going to be ohms checking or amp checking some solenoids. There's 2 different powers for those. Also, I'd like to bring to your attention temp sensors 9 and 13. So number 13 and number 9. 2500 ohms at 68 degrees Fahrenheit. We're going to talk about temps a little bit more in the next slide. Also, you see I don't give any ohms readings for input speed sensor or output speed sensor. They're very high. In my opinion, they're pretty much worthless to check with ohms. I do give it a little bit later in a couple slides. I'll point that out. Here's the temperature chart. Temperature is 104 degrees. You're at 3.2 volts. 0.29 volts, so 0.3 of a volt basically. So colder, higher amount of ohms, less ohms, the hotter it gets. This here is a picture of the first dial. Always change these. It should be connected to the ribbon like this one here. Speed sensors, with all the correct speed sensor. The output shafts, you see the air gap. Readings on the right hand side there. Input speed sensors roughly 37 to 65 thousandths. The OD speed sensors air gap is 10 to 75 thousandths. IDing of these speed sensors, there's quite a few different speed sensors. These are the most current speed sensors that we have, part numbers that is. Always advised to check with bins and make sure you get the most updated speed sensor. Don't just want to grab one off the core and throw it in there because there's a bunch of different speed sensors. Location A, which is the output speed sensor itself, the tip of that here is blue. Then they have this little band here. Normally is the same temperature or same color as location A, and B are usually the same color. On some models, they are different, so it does make a difference. So on this one, we have a blue location A and a blue location B, which look down on our chart here. We see location A blue. Here's the part number. It fits the A6MF1 and 2 transmission. Where it gets a little bit confusing, you can see if you had a blue location, the location A, if this is black, then we have what's the location of B? Black could be either here. If they're both black, you're going to be on an A6LF1 or 2. If you have the black with the green stripe in the B location, then you're going to be A6LF3. So check your colors, make sure you have the correct speed sensors, make sure the speed sensors aren't hitting any gears, make sure you do not interchange the incorrect gear tooth counts on these. I know it's being done. Speed sensor information. Scope is your best friend here. This does not have much voltage readings. It operates off of 9 volts. Each sensor has its own voltage. So 9 volts for the ISS has a separate 9 volts for the OSS. Their Hall effect sensor. Here's the ohms readings that I was talking about earlier. I don't believe in measuring the ohms. 3.8 million ohms and 5.8 million milliohms. To me, those are useless numbers. They ain't going to tell you anything. There's the readings that we got out of these sensors. Voltage signal. Rounding these numbers off a little bit, you're at about 1.6 volts high and 0.8 volts low. So over here on the chart, up here at the top of your square wave signal, this is roughly 1.6 volts. Down here on the bottom of your signal, this is roughly 0.8 volts. So you're looking at about what, 80 thousandths, 8 tenths of a volt change from low to high. It's only changing 8 tenths of a volt from top to bottom. As speed increases, the squares are going to get closer. It's going to get more faster up and down. Kind of interesting that the voltage is from 0.8. So this bottom here is 0.8, zeros down here. So it has to go up off of ground, and then it operates off of ground. They keep this to keep the signal a little bit cleaner, is what I've been told. Low amps, 7 milliamps, 14 milliamps. Scopes are going to be your friend to test speed sensors, or you're not going to figure it out with voltometer, that's for sure. Pressure taps. Brake is right here. Clutch. Pressure 2 taps. This valve body sees a lot of wear. Transco has a new kit out that addresses these two valve bore wear. Sonics also has their reaming tools for this kit, for this valve body. Matter which company you use, you need to make sure you address those two valves in this valve body, inspect them, make sure they're in very good shape. They like to wear out early. Either or fix is very good in my opinion, but most important thing is check your reducing pressure valve 1 and 2 in your valve body. Pressure testing. Look at this. Is a very confusing chart. This is solenoid milliamps over here. So on your scan tool, you'll see your milliamp readings, 500, 600, 700 milliamps, or 0. 0 milliamps is when this clutch is fully applied. You'll see 230 milliamps. or 230 psi when you see 0 milliamps. Now, milliamps on your scan tool, this is going to have to be controlled to control the solenoid to get these pressure readings of this. Take this reading here, 230 psi. I like to compare that to another circuit. Let's say we have a problem with like a 1-2 shift. Let's look at your 2-6 clutch. You see that it's on in second gear, and so is the underdrive clutch. Let's is in between first gear and see what that is. Do we have the same amount of pressures? Are they equal? Do we have a leak in one or the other? That's going to give us more information with all these pressure taps that we could use. So don't let this chart overcomplicate things. If you need a hand with it, give us a call, help on that. But good old-fashioned pressure testing. Don't let this chart overcomplicate things. Transmission learning. We have had some newer cars, 2014, 15, 16, where we had to send them to a dealer to get the trans adapts to reset so they would relearn. Some of the scan tool aftermarkets are working well also. So if you have one that's giving you a hard time, it may be worth getting a reset done at the dealer. No codes. Operating temperature has to be 104 to 194 degrees. Also like to say needs to check into like the emission side of it, where see if the emissions are relearning. If the emissions aren't relearning, most likely the transmission is not going to be relearning also. Start out with low pressure, low throttle pressure or low low apps throttle percentage. So light acceleration, low engine load, take off 1, 2, 3, 4. Get your shifting fine. Do a few down shifts, do up shifts. Make sure it's nice and smooth. Start increasing your engine load, increasing your throttle. Get up into 5th and 6th gear also, and get all the shifts working smoothly. Usually these transmissions adapt in roughly about 10 miles or so. You can do your neutral to drive relearns. Park to reverse, wait 5 seconds. Go back to park, wait 5 seconds. Back to reverse, wait 5 seconds. Roughly wait 5 seconds in each gear. You can do that from forward and for reverse to get the relearns for the shift adapts to the engagements to work better. Want to say thank you to all of our sponsors, TranStar, Whatever It Takes, Ray Bestis, ATRA, Gears, and of course Precision International, the ones that made this webinar happen. They did this for you and your training. So thank your sponsors and have them keep helping us to help you guys with your training. Thanks one more time, Precision International, Whatever It Takes, Ray Bestis, TranStar. Thank you, and you guys all have a great day.